Welcome to another video lesson with Mr. Roman. Today we're going to be talking about isolating variables, and this is from your notes on isolating variables. So if we're solving the following equation here for x, we want to our goal to solve this equation for x is to get all the x's together on one side of the equation and everything else without an x on the other side of the equation. So here I would start by adding 10x to both sides of the equation. And when I do that on the left side, I'm going to get 0 out of these x's and be left with 4m equals 2k plus 5x. Then from here, I want to get rid of the 2k on the right side, so I'm going to go ahead and subtract that from both sides. Okay, but the 4m and the 2k are not like terms, so I cannot combine them in any way. So I'm just simply going to write 4m minus 2k on the left side, and that's going to be equal to 5 times x. Now at this point, to get x by itself, we want to divide by 5 on the right side. So 5 divided by 5 is 1. And then on the left side, we divide everything by 5, which means we put the big fraction bar and the 5 underneath there. So here we can say that x is equal to 4m minus 2k all over 5. And that would be our final answer for number 1. Now let's look at your notes for number 2. Number 2 here, we're solving for y. So again, we want to get all the terms with y in them on one side of the equation, and anything without a y we want to get on the other side of the equation. So here we want to get the ny with the 8ny. So I'm going to go ahead and subtract ny from both sides. And this would give me 7ny minus 4x equals negative 2x plus 1. And then I'm going to get rid of the negative 4x on the left side by adding 4x to both sides. And this would be 7ny equals 2x plus 1. And now, to get the y by itself, I can not only divide by 7 here, but I can also divide by n. So 7 divided by 7 is 1, n divided by n is 1. But I have to also do that to the right side of the equation. So here I'm going to divide everything by 7n. And that's what the big fraction bar means. It means you're dividing that whole thing on top by the 7n. So here we can say that y equals 2x plus 1 divided by 7n. Okay, let's look at example 3. So example 3 here, we want to solve for p. And really, in this case, we want to work backward of the order of operations. And the order of operations here would say to start with multiplying the 5 times the p, then subtract the 2, then divide that number by a. And we can really imagine that there's an imaginary set of grouping symbols here that says we have to start with the top of the fraction first. So working backward of the order of operations, if the last thing that I do in the order of operations is divide by a, then to undo that, we need to multiply by a on both sides. Now here, on the left side, the a's will cross divide to give me 1. And then on the right side, I not only multiply the k, but I also multiply the negative 3 by a. So really what I want to do is create a set of parentheses there and use the distributive property to multiply the a times everything inside the parentheses. Okay, so on the left side, we'll be left with 5p minus 2 equals, here, if I distribute the a, I'll get ka minus 3a. And then continuing to solve for p, we add 2 to both sides. And we'll be left with 5p equals ka minus 3a plus 2. And then divide by 5 on left and right side. So this whole thing, again, gets divided by 5, which means we make the big fraction bar. And then we can say that p is equal to ka minus 3a plus 2 all over 5. And that is the example for number 3. Let's look at number 4. So number 4 here, similar concept. Again, I'm solving for h. So, and I can imagine a grouping symbols here. And I want to start by multiplying both sides by a 4x. So multiply both sides by a 4x. And then here my 4x's will cross divide, and I'll be left with negative h minus 7 equals. On the right side, we're going to distribute again. We're going to get 40x plus 32ux. Okay. Then we're going to add 7 to both sides. So I'll be left with negative h equals 40x plus 32ux plus 7. And then on the left side, I want to divide by an understood negative 1 here. So we can assume that there's a negative 1 here. And to undo that multiplication by negative 1, we would divide by negative 1. And then divide all this by negative 1. And really, we can rewrite our answer here as h equals negative 40x minus 32ux minus 7. So that comes from the fact that we're dividing each of the 3 terms at the top by that negative 1. So 40x divided by negative 1 is negative 40x. 32ux divided by negative 1 is negative 32ux. And then 7 divided by negative 1 is negative 7. So then this would be my final answer. Okay, let's look at the next example. Here we're solving for x, and a lot of students want to start off with the distributive property here. They want to go ahead and do this times this and this times this, and they want to say 3xy minus 6x equals m plus 1. But if we're solving for x, then if I use the distributive property, I have x now in 2 different places, whereas before it was only in one place, mainly here. So we really don't want to use the distributive property in this instant. What we really want to do is want to go back and we want to divide by the quantity multiplied to x. So here I can divide both sides by 3. So 3 divided by 3 is 1. But I can also divide by the quantity y minus 2, since it's also being multiplied to x. So y minus 2 divided by y minus 2 is 1. And then on this side, we want to do the same thing. We would divide by 3 times y minus 2. So therefore, I can say my answer here is x equals m plus 1 all over 3 times y minus 2. And you could rewrite this. If you wanted to use the distributive property on the bottom, you could rewrite it as 3y minus 6. That would also be a correct answer. Okay, moving on. Similar concept here is from the last one. So we were solving for c, and here we would want to divide both sides by 13 times u plus y. Divide by 13 times u plus y. Here the 13s will cross divide, the u plus y's will cross divide, and I'll be left with c equals 17 minus x over 13 u plus y, like that. And again, you could use the distributive property on the bottom if you would like. That would yield a 13u plus 13y. So either one of these answers will work. And moving on, we have here we're solving for n. And n here is actually inside the grouping symbols. So we need to be able to undo first what is being done to the grouping symbols. So if here we're multiplying the grouping symbols by the 12w, then we need to divide by the 12w to undo that. So we have to work backward of the order of operations. So divide both sides by 12w, divide by 12w. And then we can say that n plus 3 equals 9a plus 7 divided by 12w. Then we would subtract 3 from both sides. However, we don't subtract the 3 with the 7. That would be incorrect to say because again, there's an imaginary set of grouping symbols here that we have to pay attention to. So that's grouped inside there before we subtract that 3. So our final answer is going to be 9a plus 7 all over 12w minus 3 as the final answer there. Let's look at the next one. Similar concept here. So we're solving for d. Want to start by dividing both sides by 4c. Okay. And then we'll be left with 2p minus 18 all over 4c equals 11 plus d. And then we want to subtract both sides by 11. So here we're going to get d is equal to 2p minus 18 divided by 4c minus 11. And that would be our final answer for this problem here. And I believe we have 2 examples left. So this example, if we're solving for p in this example, we want to get all the terms with p in them on one side of the equation by themselves. So that would mean that first of all I needed to combine like terms here and here. 5pn plus np would give me 6np. And then I want to get the 7y, the negative 7y, away from those n's there. So I'm going to go ahead and add that 7y over. And that gives me 6np equals 8y minus 2 plus kp. Now we still have a p on the right side of the equation, so we can't stop the problem here and start dividing by 6n. That would be incorrect. We need to get the kp here on the left side of the equation, so we would subtract kp from both sides, which leaves me with 6np minus kp equals 8y minus 2. And again, we cannot combine the np's with the kp's because they're not like terms. So the strategy here now to get p by itself, we're going to use the reverse distributive property. So we find that the common factor between this term and this term is a p. So what we do is we pull out the p here from both of these, and we write that out front, and we create a set of parentheses here, leaving behind what is left behind. So here, 6n minus k is what you would be left behind if you pull out the p. So now we can say that since p is being multiplied by the quantity 6n minus k, now we can divide by that quantity 6n minus k. Those cross divide to 1, and then divide this side by 6n minus k. So therefore, p equals 8y minus 2 divided by 6n minus k. That would be our final answer. And then lastly, we have, in this example, solving for x. And again, we want to combine like terms here wherever we can first. So mx plus 4xm would be 5xm. And we want to get rid of the negative 3 on the right side. So we're going to add that 3 over. So we have 8m plus 3 minus kx equals 5xm. And then again, we want to get the x terms together. So we want to get the negative kx to the right side with the 5xm. So we're going to go ahead and add kx to both sides, leaving us with 8m plus 3 on the left, and then 5xm plus kx. And again here, similar concept, we cannot add the 5xm with the kx. Those are not like terms. But instead, we can use the reverse distributive property, seeing that the x's are both common here. And what we would do is create a set of parentheses of 5m plus k. And then on the outside, we have our x. And then lastly here, since we see that x is being multiplied by the quantity 5m plus k, we can divide by 5m plus k on both sides. Therefore, x is equal to 8m plus 3 all over 5m plus k. This concludes our lesson on isolating variables.